When I first saw this question, I was very surprised by the numerator, 2t plus t minus x. I kept wondering, why wouldn't they just say 3t minus x? And why not combine like terms the way we learned to do in grade 7? But then I noticed the denominator was also t minus x, just like the t minus x in the numerator. So I think a common mistake people make here is they try to reduce the t minus x with a t minus x. The reason we can't do that is because the numerator is not a product, it's not one term, it's an additive relationship, it's separate terms. You've got 2t not multiplied by t minus x. If it was multiplication, you could reduce, but it's not 2t times t minus x, it's 2t plus t minus x. So that's why it's not okay to reduce those terms. What we can do, though, is build a three-way ratio and say, okay, I've got t minus x to 2t to the sum, 2t plus t minus x. And then I can say what the question is asking for is just two columns of that three-way ratio, right? The question wants to know what's the ratio of the third column, the total, to just t minus x on its own. But if a statement gives me the ratio of any of those two columns, I can just infer the third column. And that's exactly what's happening with statement 1. You see, if 2t to t minus x is a ratio of 3 to 1, I can plug the 3 and the 1 into my three-way ratio, and I can then infer that together, t minus x plus 2t, that's 4 ratio units, and therefore the answer to the question is 4 to 1, or 4. So statement 1 is sufficient on its own. Another way to do this, a little bit more algebraic, is to take the question stem, 2t plus t minus x over t minus x, and break it down so that it's 2t over t minus x plus t minus x over t minus x. Now the t minus x over t minus x, that's just 1. I don't need statements to tell me the value of that part of the question. So then the only part that's missing is the first term, the 2t over t minus x, which is exactly what statement 1 gives us. So those are two different ways to see that statement 1 is sufficient on its own. Now statement 2 doesn't give us a ratio. Statement 2 just gives us an additive relationship. Or another way to say it is statement 2 just gives us a difference, right? You could draw a number line and you could say t is 5 units to the right of x. But just that on its own doesn't stand a chance of being sufficient to solve a ratio question, because in order to find a ratio, we need to compare distances from 0, and statement 2 doesn't give us any way to identify any of the distances of anything from 0, and it doesn't give us a ratio. So statement 2 is not sufficient on its own, and the correct answer is A. Now, just as a guessing strategy, if a data sufficiency question is asking for a ratio, and one of the statements gives a ratio and the other doesn't, it's very likely that the correct answer will be the one that says that the ratio is sufficient on its own, but the non-ratio isn't. Of course, this is assuming that there was no free info in the question stem. It was just a question that was asking for a ratio. There was no free info. One of the statements gave a ratio and the other didn't. So again, the correct answer here is A, and we can move on to the next question. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.